Okay, chapter 2.4, we're going to start with rates of change, and then we'll be going into tangent lines and something called sensitivity. So basically, let's start by just going back to average rate of change. We'd already talked about this in a previous video, and average rate of change is the change in the change in y divided by the change in x over a particular interval. And if we look at a problem, what we've got here is we've got some curve. In this case, it actually represents a fruit fly experiment. This is the number of flies, and this is the days. You guys may have actually done this experiment in your science classes. And if we take some point P and some point Q, we know that the slope of this line right here, and we'll call this A, so we have coordinates A, comma, F of A, and we'll call this B. Actually, you know what? Let's give these some numbers. Why not? We'll just go ahead and call this 23, 150. On day 23, there are 150 fruit flies. And this one will be 45, 340. On day 45, there are 340 fruit flies. And this line right here is called a secant line because it runs between 2 points on a curve. And the slope of this secant line, which is also the average rate of change of the fruit flies over time, is 340 minus 150 divided by 45 minus 23. And we get approximately 8.6 flies per day. So that's great. Okay, over the course of 22 days, we get 8.6 flies per day. But we can see from the graph that, in fact, the fly population was changing much more rapidly here, and it was changing much less rapidly here. And the question really is, what happens at a point? So, why don't you guys, I'm going to pause or stop this video right here. Why don't you guys do exercise 1, which is just a quick calculation of average rate of change, and exercise 7. And I'm going to pause here and we'll come back in just a minute.